This session is a factoring workshop. To follow along and use the resource posted here, go to www.ncmissouri.edu/ARC. After getting there, you'll click into the Math Lab, scroll down, and you will locate the Factoring Polynomials workshop. In this session, we will be factoring greatest common factors and binomials. Let's begin. First, we must look at the greatest common factor. It is a shared numerical factor, shared variables, with the smallest exponent. If there is a negative up front, we will always factor out that negative lead coefficient as well. Let's begin. In our first polynomial, we see 2x minus 8. As you can see, 2 is a common factor in both of our terms. So we will factor out the 2 by using the distributive property. Of course, we're going to look at the 2 times what is going to give me 2x. The missing factor is x. Minus, back to our 2 times what is going to give me the 8 and 4. We close off our parenthesis. To double check ourselves, we of course can use the distributive property to multiply in, and it should give us the original quantity. Let's move to our next problem. Notice that it has a negative lead term. So the first thing we're going to do is factor out that negative. I like to go ahead and change the signs at this time and then ignore the negative so that I don't have to be concerned with that as I'm continuing with the problem. So we'll cross off this sign and put a plus sign. We cross off this sign and put a plus sign. So both of my signs within my parenthesis will now be positives. Now I'm looking at numerical shared factors, of which there is none, shared variables, smallest exponent. So we see that there is an x that is shared and a y that is shared. My smallest exponent on the x squared, x to the first, is a 1. The smallest exponent on the y is the 2. Now, once again, we're going to take our GCF, compare it to the first term. So given xy squared, what do I need to multiply it by to get an x squared, y squared? The missing factor is an x. Plus, I'll bring in my 3. Then we're looking at our variables once again. We have an xy squared, and we result in an xy squared. So no additional variables are needed. I do not list either one of them. I close it off. Once again, I can use the distributive property to multiply through, and I should get the same product. The next one has a unique GCF in that it is a quantity. But once again, you see that the x minus y is shared between both of those. I like to use a little humor here and say, let's think like the mafia. Let's take this guy out. So if we're going to take out the x minus y, then let's remember to dispose of the body. So we'll get rid of these guys and we'll see what's left behind. What's left behind, of course, is 5 plus n. At this point, I would look at the 5 plus n and say, is there any additional GCF factor that's going to come out of him? One of the little keys that we can look for is to look at the power on n. If it has a power of 1, it could be done. So it kind of gives us a little bit of confidence knowing that it probably doesn't factor down any further. All right, let's go on and let's look at our binomials. On the binomials, you can see there are several different patterns that we need to consider here. So let's take a look at our first pattern. The first pattern we call a difference of squares. Notice that the first term is a square. Subtract a second square. thus the difference of squares. In which case, we're going to set up two sets of parentheses with the opposite signs. For this one, we're going to sing parenthesis, parenthesis, plus and minus. And then we simply take the square root of the first term, put it in our first position, take the square root of the second term, and put it in the second position. So let's proceed with our examples. We take a look at our first term and we see this is a perfect square, this is a perfect square separated by a minus. Thus, we have the difference of squares. So let's sing parentheses, parentheses, plus and minus. It doesn't matter which one gets a plus or minus because after all, the commutative property says we can flip-flop the factors and still get the same product. Now we'll simply break up 9x squared by taking the square root of this. So that will give us a 3x as our first terms. The second one, of course, is 25y squared. So that will give us a 5y. Okay, our next example is a little bit different because once again, see that our quantity is squared. So this time when we set up our parentheses, we're going to set them up a little bit bigger. Parentheses, parentheses, plus and minus. As we break this guy up, we'll leave him in parentheses. So that's going to give me an A plus B quantity and an A plus B quantity. Then we'll break up our 25 as 5 and 5. At this time, we'll drop our parentheses within and simplify. In this case, nothing's going to simplify. They just drop and we clean it up. So we have an A plus B minus 5, parenthesis, and A plus B plus 5. So our pattern isn't quite as evident, but we still stayed with the same pattern. Please note that the sum of cubes is never factorable under our real number system. So we state that it is always prime under our real number system. Let's take a look at our second pattern, and that involves the cubes. For the cubes, we can have a sum or a difference of cubes. Both are factorable. We have a pattern that we use that simply says, take the cube root of the first term, keep the same sign, take the cube root of the second term, and that will create our first factor. The second factor uses the first factor to be created, and we're going to use a mnemonic that says SOPs, S-O-P-P-S. The first term is made by the first term of our original factor squared. Then we keep O, the opposite sign. The first P stands for the product. Now remember, we're going to take the product of AB and disregard the sign. The second P stands for a plus, and then finally we will square the second term. Let's try an example. So we're going to take the cube root of 8x cubed, which of course is 2x, plus, and now we're going to take the cube root of my second term, which is 3y. We will use this quantity to create my missing trinomial factor. Let's put the mnemonic down here, S-O-P-P-S. So the first S stands for squaring. We'll come in and square the 2x squared, which gives me a 4x squared. We'll keep the opposite sign, so since my first factor is a plus, this will become a minus. Let's cover up this first symbol here, and let's take the product of AB. which is of course 6xy. We'll now take my second p, which stands for plus, and we'll square the second term, which is 9y squared. So how does it change when I have a difference of two cubes? It's still the same pattern. I take the cube root of the first minus the cube root of the second, and that creates my first factor. The trinomial will be found by taking the first factor and once again applying our mnemonic SOPs. So we square the first term, which gives me a squared. It was a minus, so the opposite sign is a plus. We take the factors of AB, that becomes my middle term. My second p stands for plus, and then finally we square the last term, b squared. Let's apply it to an example. So let's take the cube root of the first term, which of course is x. Keep the same sign, minus. Take the cube root of the second example, which of course is 4. Be careful with the cube root of 64. Sometimes we make the mistake of calling that an 8. Okay, let's come over here and let's write our mnemonic, S-O-P-P-S. S, of course, stands for square the first term, which gives me x squared. My opposite sign will be a plus this time. We take the product of x and 4, which gives me 4x. My second p stands for plus, and take the square of the second term. So 4 squared is 16. Thank you for being a part of our GCF and binomial workshop. If you would like to continue the workshop, we will be looking at trinomials next.